Well, here we will go to the very last example of this chapter. That is example 11. Okay, example 11. Well, the problem goes like this. The pump of a water distribution system is powered by a 15 kilowatts electric motor whose efficiency is 90%. And the water flow rate through the pump is 50 liters per second. Okay? The diameters of the inlet and the outlet pipes are the same, and the elevation difference across the pumps is negligible. And if the pressure at the inlet and outlet of pump are measured to be 100 kilopascal and the 300 kilopascal absolute, okay? Here is not gauge pressure, but the absolute pressure, okay? We need to determine the mechanical efficiency of the pump, okay? How can we do this? Well, here we would focus on this pump to see what's the input, what's the output, so that we can formulate the formula for the mechanical efficiency of this pump. So how can we do this? First of all, we know that this energy output of this pump should be the change in the mechanical energy. This change in the mechanical energy, E dot, the mechanical power that's available, should be equal to the mass flow rate multiplied by what? Here, we would neglect the KE and the PE changes, okay? Because the elevation difference across the pump is negligible. And here, we also do not have any information about the velocity. So we will neglect KE and the PE, okay? We neglect delta KE and delta PE in this case, okay? So only the flow work will change, minus PV1, okay? That's the difference between two flow work. And here we know that water is incompressible liquid, so that we can pull this V out, okay? Because the both V's are the same, so m dot V times P2 minus P1. Okay? So m dot V is the total volume, or the volume flow rate, okay? Times this P2 minus P1 equal to V delta P. V delta P. But what is V delta P? Well, because the volume flow rate is 50 liters per second, but not m cube per second, so we need to convert it to m cube first. How can we convert this? Well, we will divide it by 1,000 because 1,000 liters is equal to 1 m cube, okay? So we have this one times the change in the pressure, okay? However, this one is in a kilopascal, so we need to multiply by pascal so that we can get the power in the SI unit or in the appropriate SI unit. So it is 50, okay? The 1,000 cancels times 200, okay? 10,000 watts. Or we can write it to be 10 kilowatts. 10 kilowatts, okay? That's the energy output or the mechanical power output from this pump. How about the input? The input should be the energy input from a motor. And we have given the energy input to the motor as well as its efficiency. So the E dot input should be 15 kilowatts multiplied by this 0.9. It will be 13.5 kilowatts. Okay, now we can get the pump efficiency. That's eta pump equal to the useful energy power output divided by 13.5. That's energy input. Okay, we will convert it to percent so that we have 10 divided by 13.5 times 100%. So we can get this one. This one is 74.1%. That's our answer. Okay. This example is done.